Have you ever wondered how apps instantly check for repeated characters in your passwords or highlight the longest unique word streak in text analysis? That's the magic behind LeetCode's longest substring without repeating characters, a pattern mastery 100 essential and a frequent favorite in Facebook and Google interviews. Over 40% of candidates overthink this. Let's get you in the winning group. Let's tackle this using the basic framework. This lets us break down the problem, analyze trade-offs, design a clear plan, and check our work. Just what interviewers want to hear. We're given a string and need to find the length of the longest substring without any repeating characters. For example, in ABCB, the answer is 3 for ABC edge cases, empty strings, all repeating characters, and mixed cases. Suppose you're designing a text editor that suggests the longest word or phrase with all unique letters for cryptography or password suggestions. This problem helps you power that feature efficiently. A brute force solution checks every substring, but that's O(n) squared time, much too slow. The optimal approach is to use the sliding window pattern with a hash map, or set, to track characters and their indices. This lets us expand and contract our window efficiently as we scan, guaranteeing O(n) time. Here's our plan. Use 2 pointers, left and right, to define the current substring window. Use a hash map to remember the last index of every character we've seen, as we scan from left to right. If the current character is already in our window, i.e., in the map and its stored index is greater than equals left, move left just past its last occurrence. Update the character's last index in the map. Track and update the maximum window size seen so far. After scanning, return the max length found. Now, let's break down the first Python solution for longest substring without repeating characters, a clean sliding window strategy that tracks unique characters and expands or shrinks the window to find the longest repeat-free stretch. We begin by defining the solution class. LeetCode looks inside this class to find the method it should run. This defines our function. It receives a string s, and our job is to find the longest stretch of characters with no repeats. We create a set called scene. This acts like a quick lookup basket that stores all characters currently inside our sliding window. Using a set gives us O(1) lookup time, helping the whole algorithm stay O(n). This is our left pointer. It marks the beginning of the sliding window. We initialize max_len, which will keep track of the longest substring without repeating characters. We now loop through the string using r as the right pointer. This right pointer expands the sliding window 1 character at a time. If the character at the right pointer is already in our set, that means we've hit a repeat. To fix that, we shrink the window from the left until the repeated character is removed. We remove the character at the left pointer from the set, because we're sliding the window forward. Then we move the left pointer 1 step to the right, narrowing the window. Once repeats are cleared out, we add the new right pointer character into the set. At this point, the window contains only unique characters. Here we update our longest window length. We compare the current window size, r, l+1, with the best one we've seen so far. Finally, after exploring the entire string, we return the maximum length found. And that's how this algorithm works. It first sets up a sliding window and a set for tracking characters, then expands and shrinks the window efficiently to avoid repeats. Efficient, simple, and elegant. Test case check. Let's walk through it. Input s equals abc_abc_bb. Let's test our function using this input string, abc_abc_bb. This represents a sequence of characters where we want to determine the length of the longest substring without repeating characters, essentially the longest stretch of unique letters. Quick logic check. As we slide through the string, the first 3 characters ABC are all unique length 3. When the string repeats at index 3, we reset our window. Several repeats follow, but no substring becomes longer than the initial ABC. So the maximum length of a substring with no duplicated characters is 3.output 3. And that's exactly what our program outputs, 3. It matches the expected result perfectly, confirming the sliding window logic is keeping track of unique characters correctly. So, our implementation is correct. The algorithm efficiently scans through the string using a dynamic window to track unique characters, accurate, optimized, and fully validated by the test case. We begin by defining the solution class. This is where LeetCode looks to find our method. This defines our function. It receives a string s and returns the length of the longest substring that contains no repeating characters. We create a dictionary called index. This will store the most recent position of each character as we scan through the string. This small change makes the algorithm run in O(n) time, because we never move the left pointer backward. This variable will track the length of the longest valid substring we've seen so far. L is our left pointer, marking the start of our sliding window. We now move a right pointer r across the string while grabbing each character ch. This expands our sliding window. This checks whether the current character has appeared inside our current window. If it has, we need to adjust our window to remove the duplicate. Here we move the left pointer just past the previous position of the repeated character. This ensures our window contains only unique characters again. We update the latest index of the current character, overwriting any previous entry. Now we compute the length of the current window, r, l+1, and update max_len if this window is the largest so far. Finally, we return the longest substring length we found with no repeating characters. And that's how this algorithm works. It first sets up a sliding window with an index map, then moves the pointers intelligently to skip past repeats while tracking the longest clean stretch of characters. Efficient, simple, and elegant. Highlight input box, s equals bbbb. Let's test our function using this input, bbbb. This string represents a sequence of repeating characters, and our goal is to find the length of the longest substring without repeating characters. Quick logic check. Here's why the solution works. In this case, the string contains only one unique character, b, repeated 5 times. For example, the first character b gives us a substring of length 1 with no repeats. The moment we move to the second b, we immediately hit a repeat, so the window resets. And the same thing happens for every subsequent character. So the longest stretch of non-repeating characters is simply b by itself, length 1. And that's exactly what our program outputs, 1. This confirms that our code is working correctly and passes the test case. So, our implementation is correct. The algorithm successfully finds the longest substring without repeating characters, efficient, accurate, and reliable. So, what did we just learn? This problem, longest substring without repeating characters, is one of those perfect tests of logic and pattern recognition that shows how well you can think through a real-time data problem. Breakdown recap. We started by understanding the goal, finding the longest substring in a string that has no repeating characters. Essentially, it's about tracking a clean stretch of unique letters. Assess recap. Then we discussed why brute force just doesn't cut it. It's too slow, checking every possible substring. Instead, the optimal approach uses the sliding window pattern combined with a map or set to keep track of characters efficiently. Structure recap. We planned the logic step by step. 2 pointers to define the window, a map to store character positions, and a way to slide the window forward whenever we hit a repeat, always keeping track of the maximum length seen so far. Implement recap. We then implemented the logic cleanly and ran it on LeetCode, no errors, just a smooth execution. Check recap. The test cases confirmed everything worked as expected, and our solution passed across all examples. Closing insight. The real takeaway? Sliding window problems are all about balance, knowing when to expand and when to contract. Master this technique, and you'll fly through a whole category of string and array problems with confidence.